So yeah, we on this A/B testing study, we had some information about like each of the each account, which consisted of like the account age, prior whiteboard sessions, the region, number of collaborators, the number of templates used, the number of AI suggestions used, average whiteboard duration, whiteboard actions per sessions, and etc. etc. So here we checked if the log transform distribution is close to the normal. So, and we also tried to see how actions per sessions can predict the session duration, and we realized the log transformed of average session duration follows a logarithmic distribution over the number of actions per sessions. Okay, so if we have the number of actions, we can kind of predict the session duration. The last thing we did, we tried to check different numerical predictors and the distribution of the average duration and the number of suggestions per session over some other fields of the data set. So here we did it for the three of them, the accounts per day, whether they had whiteboard sessions previously, and the number of collaborators, among which the account age didn't give us any like a specific information about the number of AI suggestions used. However, we could see that for prior whiteboard sessions and the number of collaborators on a somewhat normal distribution, it's both of them are similar to like normal distribution, but they're most like quadratic, a quadratic figure diagram here. Yeah. So what we want to do is to repeat the same thing. Here we wanted to check numerical predictors. Now we want to check categorical predictors. Okay. Some categorical columns of the data set here are device type. Okay. The AB group, device type, and the region, the plan region. So first thing we're gonna do, you have the pseudocode here. If you've already done this part, you can proceed with the next parts. But otherwise, you can come and we can do it together. So we're gonna define the categorical predictor variables, and then create the visualizations similar to the previous ones, and then we're gonna have we're gonna analyze treatment effect and evaluate model fit. So let me clear this here and then start coding together. So I remember that we have categorical predictors. The most important one is the AB group, whether they have been in a control or the effect group. The device type, I think the device type, we have 3 different types. I'm gonna check it later. And the plan region. Okay. Let me see. On the devices, we have tablet, desktop, and mobile. Yeah, we have 3 different kinds of the devices here. So again, we're gonna be working with the logarithmic transfer. I shouldn't have been writing code here. It should have been done here. Just let me. Okay, I should scroll up here. Okay, so I'm gonna paste them here. Okay. So we will be still working with the logarithmic transformation of the average whiteboard session. I think we have already defined this here. Have we? Yeah, but just for the sake of like keeping that in mind that we're working with the logarithmic transformation, I'm gonna do it here. It's not necessary because we have the line of the code in the previous cells. And we're gonna have the figure and the axis. Subplots. Predictors. We're gonna have one row, and the number of columns will be equal to the length of this Python list here. Okay, which is going to be 3 in this case, and let's have the fixed size equal to 30 to 5, similar to okay. Okay, subtitle. Session duration by categorical predictors. Okay, so now we're gonna loop over the categorical predictors. We're gonna hold the indice and the column name. Enumerate. Okay, so we're gonna sort these, sort the amount of, like, we have different categories under each column. So we're gonna define levels by sorting these. And we're gonna have the unique values of them. So we have, like, for this, let's say for this column here, for the device type, we're gonna sort them, and we're gonna have unique values of this column, which is gonna be tablet, desktop, and mobile. Okay, these three. Okay, and then we're gonna group columns based on the unique values under each column. Okay. Okay, so logarithmic duration is the log transform of the column average white precision duration per minute, and df_AB is the data set related to this Phigma ABS study. So if you have forgotten these namings, this is just a reminder that df_AB refers to the data set, and log duration refers to the log transformation of this specific column. Okay, so we're gonna group these values. Okay. Okay, so we're saying choose this column in this data frame. If the column is equal to level, we're gonna group the rows that share the same level under a specific column. So we're choosing this column. We're saying we're gonna group all the rows whose device type is tablet, and we're gonna put them in this grouped variable here. Okay, So now we're gonna have a box plot to evaluate how these categorical predictors predict the session duration. And I'm gonna explain why we are choosing to have a box plot instead of like here we had bar charts and scatter plots. I'm gonna explain it. If you think about it, it's kind of obvious why we're doing this. So I actually invite you to think about why we are using a box plot here instead of a scatter plot, okay? Okay, light blue. And for the median, we're gonna define it by red and the line width of 2. Okay, we're gonna set the titles and subtitles and stuff. The column name. So the x-axis is the column, which like in this case can be the device type, and we're going to see how it influences the distribution of the session duration. Okay, so the y-axis would be log of session duration in minutes. Okay. Okay. Let's see what we have. We should be expecting some, like, as usual, we should be expecting some syntax errors, but let me restart the whole thing because the previous cells might. Okay, let's run all the cells. Once again, libraries are loaded. Okay, data is loaded, summary is given. We have this, we have this, we have this scatter plot. Okay, yeah. What's the problem here? Figure. Subtitle. Okay, what's the problem here? It's not subtitle, it's super title. Okay. What else? We don't have light blue here. Okay, we shouldn't be having this space here, I guess. All right. Okay. So here, so the y-axis shows the session duration in minutes, the logarithm transformation of the session duration, and for each of the categorical, I can actually close this. for each of the categorical predictors, we can see how shifting from one category to the other influences the distribution of the session duration. My question here for you is, which of these three categorical predictors do you think have a significant effect on the distribution of session duration in minutes? Like, for which of these three categorical predictors, if we are given the type, we would be expecting to see a different behavior in session duration? Yeah, exactly. Yeah, Tim and Minaho are right. It's gonna be device type. Why is that? So first of all, let me answer you the question why we decided to have a box plot here. So we have discrete variables here. Like instead of like having continuous variable, here's numerical variables, which ranges from like 0 to 700 here. Let me explain this, Tim, and I will return back to you. So instead of having a continuous variable here, the numerical variable, which ranges from 0 to 700, we have discrete categories, okay? So the box plot shows the distribution of this variable over this group of this category, okay? So shifting from group A to group B here, we see some differences. Like we see that the median for the group A, which was the control group without any AI suggestion, is a bit lower. The maximum here is a bit lower. The minimum is a bit lower. And we can technically say that an average user in group B has a bit longer duration compared to a user in group A. If we go to the plan region, which we have 4 regions, it's EU, Asia Pacific, North America, and Latin American. We can see that there's no significant difference between each of the groups within this category. Okay, so like let's say this is if they're like this is probably Asia and Pacific if we order them in an alphabetical order: Asia Pacific, Europe, Latin American, and Northern American. So there's no difference. But as Tim and Minahill pointed out, we can see that they are way different. Like we have desktop, mobile, and tablet. And the mobile users apparently have way lower session duration, which technically makes sense because we don't expect a user on a mobile device to be using Phigma, which is a design application, for like long sessions. Okay, so let me see what Tim has asked. Can we label the ticks instead of using numbers for the box plot along the x-axis? Yeah, we can. We are actually let me see how when we're doing this. Set X label. Let me see if anybody else has any question, and then I return back to you. Okay, so I just want to make sure that you guys know why we have decided to have a box plot here, and how this device type makes a difference in the session duration. tick labels. I should be looking for tick labels. Tick labels. Batch artist. Let me see. You figured it out? Okay, it's cool. It's just tick labels levels in. Yeah. I was looking for the exact variable that I had to change. Yeah, because like I don't usually memorize the syntax. Okay, so tick labels. Okay, cool. And the box plot. Here we have this should be tick labels, yeah? Instead of tick label. Yeah, this is it. Yeah, I was right. I knew that I had to change this, but I didn't pay attention to this S here. Okay, so if we have like tick labels here, and if we just put it as this, we have indices here, so yeah. Okay, let's proceed to the next part. Okay, so we're gonna do a bit of feature engineering here. Okay, so we have two groups. Okay, we know that's device type and plan region. We're gonna have like dummy variable trap. Okay. So we're gonna do a dropping, hot encoding and dropping, and we're gonna perform log transformation on count variables. Okay, these are all count or duration variables, and we can somehow see that it has a bit of a skewness to the left. So we're gonna apply a log transformation over them. Okay. And we're gonna exclude AI suggestion used, because like this is actually the behavior we want to watch, so we don't want to include it in the feature engineering part. And we also want to exclude whiteboard actions per session. Okay, but can somebody tell me why it's a good idea to exclude whiteboard actions per session while we are preparing for feature engineering? Okay, so as you know, for feature engineering, we're gonna do some transformations. We're gonna like do some cleanings over the data set. We're gonna pick up some of the behaviors of the users, which we think, and we might have a guess that has an influence on the session duration. Okay, that's why we apply log transformation over some columns. Okay, because like we have seen the distribution here and we want to turn it into something normal. But why do you think it's a good idea to exclude whiteboard actions per session? And if you haven't, okay, Atif says sessions are too short term of a window to examine. That can be one idea. And I also want to ask you, if you haven't understood my question, you can also ask it in the comment section, okay? Minaho says, since the more actions you have, the more time you have. So isn't this metric redundant? That's also an interesting idea. I'm not gonna give out any comments right now, but like, yeah, I think it's pointing towards something meaningful. Mina Hill is pointing out something meaningful. Barnacle says a strong correlation with average session duration regardless of the differences between the AI versus no AI group. Yeah, exactly. Thank you so much. So as we saw here, there is a really nice correlation between action per session and average session duration. Okay, so it follows a logarithmic distribution. So having one, Tim says, besides just redundancy, I'm curious if it'll skew the predictions, introduces bias. Well, in this case, they're almost they mean the same thing. They almost mean the same thing because like this diagram here shows it. Having one of them gives us the other. Okay, so they are like equivalent, somehow equivalent. We can claim that these are equivalent. So yeah, first of all, it's redundant. Second of all, bringing a column which we already know has a high correlation with the average session duration increases the bias, which also might increase the risk of overfitting. Okay, so let's go and do some feature engineering. So in the first step, we're gonna do binary encoding for the AB group. Okay, so we're gonna add a column which is called AB group, but encoded, which is equal to okay, this is gonna be an integer, okay, and we're gonna get the group, okay, and check if it's equal to treatment. AB, this should be in a quotation mark. Okay, so it says that the output of this is a true false. True false can also be turned into 0 1. Okay, so it's a binary encoding. Okay, and we're gonna do kind of the same thing for the device. Okay, so we're gonna have a dummy for the device. So we're gonna produce dummies. DFAB. We're gonna check. It was device type. Yeah, it was device type. Prefix equals to device. First is true, and again as type int. Okay, same thing here. We're gonna get the value under the column device type. Okay, we know the prefix is device, and we're gonna drop the first row because the first row here is this. Okay, and we're gonna turn it into integer. Same thing for the region. Dummies. So I'm just gonna copy this. Okay. Region. Plan region. Okay. Okay, my device is a bit slow, so let me see what I can close to increase the speed of it. Okay, I can close Discord. I hope you don't have. Okay, I can have actually my phone here. Let me just bring my phone. Okay. If you have any questions on Discord, I'm gonna be checking it on my phone, so I'm gonna also close Discord here. Okay, that's better. Less lag. Okay. So we have dummies for the categorical columns. Let's apply the log transformation for the numerical columns. Okay. So that's gonna be the same thing for all of them. Okay, let's log LP. I'm sorry. LP, DFAB, count age days, right? Yeah. Count age days. Prior whiteboard. Prior whiteboard sessions. We're gonna do this for number of collaborators. We just worked with these three, yeah. The count age days, prior whiteboard sessions, number of collaborators. So let's ignore the fourth one because you're gonna do it yourself. Okay, and now let's create the feature matrix. Okay. So the matrix is pd.concat. This one's gonna be function, okay? Okay, we know that this is the encoded, but we're just gonna simply rename it. Okay. We're gonna check features are completed. Okay. Okay, this is something that we didn't include, so I'm just gonna remove it here. Okay. Okay. Okay, let me check if we have all of them here. AB group, yeah. Account age, prior whiteboard, number of collaborators, that's rename. Device dummies, region dummies, okay, and let's close to one. Okay, and let's do the quality control, okay? Type these again. I'm just gonna put this here. Okay. 3. Okay. Yes, I have forgotten a comma. Okay. So we have the feature matrix. It's done. We have like 2,000 rows, 9 columns. We don't have any missing values. We have these feature columns here, all pretty, and we can see the log transforming applied to them, and we can see that we have this. Is it for checking in feature matrices? Yeah. We're making sure. Like, let me just. Yeah, it's technically for the same purpose. So, we only want to make. We want to make sure if we don't have any missing values. Okay. Yeah, rows and columns. You're welcome. Okay, so you can explore this more, okay, by having the matrix, and similar to what you've done previously in the labs. I'm not gonna repeat them again, but we're gonna have the regression, okay. Any questions so far? Okay, I suppose everything's cool. We haven't done A31 yet, but what's your question? Okay, you're asking about the... Oh, okay, sure. Sure thing. Just one thing that I would like to Okay, sure. I Okay, I just wanted to point out one thing, is that the pseudocode that we put here, it's not like we expect you to do exactly as what is described in the pseudocode, okay? If you have if you find different ways of doing the same thing, you can do it, unless as long as you have your own interpretation, and you can explain your rationale behind making the decisions. Okay, so yeah, no worries. And Aliza will answer the specific question as well. Okay. Okay, so let's have the regression results. Okay, so this is pretty much descriptive results that we have here. Before we proceed, I would like to ask, what do you understand from this report here? Okay. Just let's take a moment. You already know what each of these mean, okay? I think I've done a mistake here. I've made a mistake. I think we are missing, because we have 2 devices here, but we're supposed to have 3 of them. Yeah. Yes. Yeah. Okay, so I have to do this again. Okay, now it makes sense. Okay, so if you've already done this before, you might already have the answer. But if you haven't done this before, I would like to invite you to take a look at this table, what it says, and discuss a bit about what it tells us. Okay. Mina Hill says only significant p-value is for plan region Latin American. Okay, let's have that as one inside. For the others, do you find what we're seeing this confusing? This is a good question. What does each of these columns mean? That's a good question to begin with. Does anybody has an answer? Yes, Tim. This is the confidence interval. Okay, so for the AB group, we can see the interval falls between these. So like this technically means the 95% confidence intervals. Okay, so this 0.025 means the lower bound, the 2.5th percentile, and the 0.957 means the higher bound, the upper bound. Okay, so to read them practically, we can see that for AB group, this interval is 0.181 to 0.253. What does it mean? This means the true treatment effect is somewhere between plus 18% and plus 25%. Okay, so with like 95% confidence rate, we can say that this AI feature being added increases the sessions from 18 to 25%. Okay. On the other hand, Minahill said the only significant p-value is for plan region Latin American. Okay, so here we have like each of these rows can be interpreted as I just explained. Okay, so if you want a 99% interval, okay, so if you want to, instead of like a 97.5%, we want 99%, these two numbers turn to be 0.005 and 0.997. Okay, that then we can have more like certainty. I think let me check the course website to tell you where exactly Ali Reza has taught you this in slides. I think it was okay. You told them in week 2, yeah, when you were talking about some math. Yeah. I just wanted to point out what matters here is just like understanding. Okay. Yeah, I just wanted to point out what's important for us here is the p-value and the significance that you might be dealing with. Adriza has talked about them both in week 2 and previous week. So it's 7:40. Okay, I'm gonna spend like the last 20 minutes of the lab uploading your midterm questions and answering the questions that you have. So I'm going to proceed with interpreting the model. Okay. Do I have a message? No, I don't have any messages here. Yeah, I will proceed with interpreting the model, doing this part together. And then I will upload the questions and you can read the questions and let me know if you have any questions for your midterm. Okay, to interpret the model, we're gonna input the regression model. We're gonna input the experimental data frame. We're gonna evaluate it using the R-squared value, and we're going to analyze treatment effect, and we're going to extract significant predictors. Okay, these are close to the topics that Ali Reza has covered in the previous week's lecture. Okay. Okay. So. I'm just gonna have the print functions here. These are pretty much descriptive. So yeah, we have our model here. Okay, and actually this SM comes from this library here. Okay, so stats model, stat models is imported as SM, so we're asking stat models to generate this model for us. And then we're gonna have R2N as just R squared JSON. We're gonna analyze the treatment effect. So we're gonna calculate the coefficient. Again, we're gonna directly ask our model to gives us the coefficient for this column, and the p-value is that so we have y equal to logarithm of duration. Okay. Okay, so we're gonna return it back to the raw minutes. Okay. This -1 is for the exponential function, okay? This -1 is for the exponential function. Keep that in mind. Control mean is equal to so we're gonna have those rows of the data frame which are in the control group, okay? Okay. And we're gonna calculate the mean of this. Okay, so we're gonna have coefficient and p-value for AB group. Okay. Yeah. This part here gives us coefficient and p-value. This does the back transformation for us because y was log transformed, as I explained to you here. Okay. And then here we have computing the average session duration of control group users in raw minutes, and we're going to use this as a baseline to anchor the effect in real units. This line here converts the percentage effect into actual minutes. Okay, so let's say if the control mean is 30 minutes and the treatment at 24.2%, this increase is 7.3 minutes. Okay, this makes the finding concrete, and we can actually interpret and understand it better. Okay, and let's print all of these here so that we can check them. I'm not gonna write them again. So group coefficient is here, p-value is here. The back transformation, I think Mina Hill asked. The -1 is for transferring the log to an exponential. Okay. Like when you have the inverse of the function, you have a -1. It's like just how the inverse function works out. If like turning exponential to logarithmic and vice versa is something that you don't remember right now, I suggest you do a little bit of research. Yeah, okay. Let me finish this. If I had time, if we have time, I'm gonna explain why we're doing it here. But like, it's a bit of the basic of transforming these two functions to each other. Okay. Where were I? Okay, back transformed, which is, this is gonna be floating point. Okay, and at the end, these are just like print functions to have these variables here. And at the end, we're gonna check significant predictors, significant with P. And from that, we can, like, this can help us understand it, but like, here we're gonna ask our model OLS to give p-values where the p-value is less than 0.5, 0.05, and we're gonna sort them. Okay. Okay, so the answer is here. See, the log of duration, okay, the model says the coefficient is multiplied to AB group, okay? So when you move from the control to treatment, okay, the logarithm of the duration increases by like, let's say, I don't know, 0.217, okay? So it means this is equal to the exponential of 0.217 is equal to 1.242, okay? So it means that the treatment users have 1.242 times the session duration of the control users, okay? So if we want to measure the increase, okay, so x multiplied by 1.242, okay, is equal to z. So if we want to measure the increase in z, okay, we're gonna say, okay, it's multiplied by 1.242. If I subtract 1 from 1.242, what remains is 0.242, okay? So it means the increase is 24.2%, okay? Sorry, Adriza. I didn't see your comment in the chat. Yeah, yeah, yeah. That's what happens here. Okay. Anyways, let's run this and see if we have any syntax errors. I would be expecting some syntax errors here. Okay, it's taking a bit of time. Run again. Okay. So one other thing is that what does this mean here? It means that when we put the f behind a string on Python, it means that we can have some variables within the text. We normally cannot have variables within the text. So when we put the f here, it means that, okay, if I put a variable within crochet within curly brackets here, I can print the value that they have, and this means that this is a floating point variable, and I'm gonna have up to 4 digits of floating point. Okay, so this is what it actually means. Okay, why isn't it running? Okay, do I have to like restart it again? I don't want to have to restart everything again, so let me just run this one more time. Okay, it runs, no problem. What about you, sir? Do I have to run you again too? Apparently I have to. Okay, while this is running, I will upload your midterm questions. So let's just Okay, my system is a bit lagging and I cannot upload the file on Canvas. Let me refresh everything here. Yeah, I'm trying to upload the exam file on Canvas because, yeah, that's the same file. I'm trying to put it like on the midterm exam page. So if yeah, thank you so much. Okay, so yeah, I just wanna show the output of the code that we have here, but like it's taken a bit of time to run the cell. Okay. It makes sense. Like, what we value here is your interpretation and the rationale behind. Yeah. Yes, you can. You should click on build, and then a page opens up for you. Let me try again. Actually. Oh, I can do it. I can do it. Okay, I just did it. Return. Okay. Okay. Yeah, right now you must be able to see the exam file. Yeah, the exam file on the midterm exam. Just let me make sure that it's available. It is available. We're past 7:45. Okay. So just let me. Yeah, I'm gonna put the link here. Okay, so now that we have the results here, okay, we have the results here. Okay, we're gonna interpret it together. Sorry, I just need to answer this question. Okay, so we already had these two here as well. Okay, and significant predictors, device desktop. Device tablet, being in the North America, and being in the EU, and relatively we have 8.5 minutes longer session duration in the treatment group. Okay, so apparently having that AI feature is effective in increasing the session durations. Okay, yeah, that's it. Okay, and at the last part you have the regression diagnostics, which I think we cannot cover today. And at the end you're gonna have a exploratory interaction analysis, like you will like bring all of this that you've realized so far together in this part, and you're gonna have the visualizations. And then you proceed with the logistic regression, which is something that Adriza is gonna talk more about tomorrow. Yes? Yeah, okay. Uh-huh. Okay. Okay. Okay, sure. Okay, sure. Let's keep this as a... I'm gonna update it on GitHub. Okay, so let's take a look at your midterm exam.